Hello, welcome to the first edition of Core Thoughts. I'm Arjun Jairam, founder and CEO of Baton Systems. In this series, I thought I'll talk to you a little bit about the innovations that are happening in the post-trade space, very specifically about the deployment of technologies like distributed ledger in financial markets. Now, we've been at it for quite some time, so I can tell you how we think about digital market infrastructure for financial markets. When we think about critical market infrastructure, you need to make sure that it is truly secure, it is extensible, it is interoperable, and it's got certain governance controls in place. So let's talk about what we mean by security for critical market infrastructure for financial markets. Now, when you think about security, it has to be more than just lip service. You have to really think about this and make it part of the core culture of a company. The first, I look at this as four main categories. One, you need to make sure that the software that you develop is indeed secure and you can stand behind it. The second one is making sure that the access to this software is also tightly controlled and it is truly secure. And the third, any data, then when software executes, there's going to be data generated. You want to make sure that this data that is generated is very confidential and therefore needs to be very secure. And the last part of it is extending that to make sure that the access control for this particular data has got certain auditability and certain entitlements that go along with it. Let's talk about each one in a little more detail. The first one is, how do you build secure software? And I believe that secure software is not just one or two processes, it's a mindset. It's a cultural thing that has to be embodied by an organization. It took us quite some time to appreciate this. I'm glad that we went through a very thorough SOC 2 Type 2 audit process about 3.5 years ago. And since then, this is part of our culture. We think about security right from the design phase of that software, which means that you have to go through the continuous delivery, the continuous integration, continuous delivery of the software development process, goes through vulnerability testing, it goes through pen testing, eventually it gets into the user acceptance stage and eventually into production. This makes sure that the software that you develop is indeed secure. But that's not enough. There is a process that's required in this. What if you have to think like a hacker and say, what if somebody maliciously wanted to inject bad code into the software? And this is where you have to do what is called segregation of duties. That is, even if a software developer wants to do it, it will go through certain processes and certain checks and controls before it finds its way into production. And this is something that you have to incorporate very early on into your development cycles. Okay, so now that you have developed secure software and you've deployed the secure software onto the cloud, you need to make sure that the access to this software in and out of a financial institution is also secure, because these are trade level data. This has to be very, very secure, both for the bank and for the clients of the bank. This is very critical and very sensitive financial data. For that, the way we look at this is there are certain access protocols that you need to have available, and these are secure access protocols. The second one is all the data formats that you have to be able to make sure that it incorporates all the data formats that a bank would need at this point in time or a financial institution needs at this point in time. And the last part of it is, how do you make sure that there is enough governance around this? Let's talk about each one. So the way I look at access protocols is you have three modes in which you broadly access data. What I call push, pull, and streaming. And I say push, pull, and streaming in the context of the Baton software or the SaaS software. We push data out. So you want to make sure that any data that is available here, you are able to push this back in near real time back into the enterprise, so that an enterprise that is a bank or a financial institution can use it in near real time. So that is a push part. The second one is a pull. How do you ingest this data in a secure manner? And the last part of it is the streaming. You want to make sure that real time is something that is part of our culture. You have to, everything is moving to real time. So you need to have real time secure access protocols in a variety of different formats. Now I'm going to move from secure access protocols into the data formats. Data formats is anything that you can think about, which is, it should be in a CSV, TSV, XML, TRML, FixML, fixed messages, Swift empty messages. All of these are different data formats or message formats in which messages will go. The most important thing is that all of these pipes are truly secured. That is, there is nothing that is unencrypted that's going through these pipes. Whatever the data format, it is always encrypted, which means that digital signatures are a core part of it. You should not be doing anything that does not have a digital signature. So everything is truly encrypted at all points in time. The next part, let's talk about data. the data that is actually generated on the platform. Now, when data is generated on the platform, you obviously have to secure that data by encrypting it. That's not enough. You have to make sure that the keys that you use to generate that data is also secured, and it is behind certain infrastructures, cloud-based infrastructures such as key storage management. Key management is something that you have to go through. So this is what you'd expect modern softwares to be able to do. And this is where the infrastructures that a cloud provides is significantly better than what would be available inside a bank at this point in time, or inside what data centers provide at this point in time. Because it is something that our own engineers will not be able to decrypt it if they ever wanted to. And lastly, let's talk about computes. Now, the computes is something that is just emerging at this point in time. When I say just emerging, this has come out in the last 2 years, and that is a new kind of architectures that the chip processors are doing. Now, this may not be 100% relevant to what we do here at Baton at this point in time, and I'll tell you a little bit about what it is. First, let me tell you about the technology. So Intel has recently come out, or about 2 years ago, has come out with a new kind of architecture where all encryption happens on the chip. That is, no matter how you store the data, all encryptions happen, app-level encryption happens on the chip. Encryptions and decryptions happen on the chip, which means that other software or other malicious software, once it's executing on the chip, will not be able to get access to your data. Now, this makes a lot of sense. When you have lots of software that's running on the same machine, it makes a lot of sense. But in a software like Baton, we deploy what is called a single tenant architecture. That's Bank One software will never have the same servers. It will not sit on the same servers as Bank 2 software. So it may not be directly relevant at this point in time, but we can see that as infrastructures get more complex and more workflows and third-party apps get onto the platform, such as Baton, this will start becoming an important part of it. We are monitoring this at this point in time, but there's a cost element to it. It's actually quite expensive to have this particular software made available at this point in time, but that's why we are keeping a tab on this. It's also, you need high-end servers in order to access this particular feature. Now, we are exploring this with a couple of our banks clients who have asked us to deploy the Baton software inside their enterprise. And so this kind of an architecture does make sense when you're deploying the software on bare metal. So as you can see, software is not just a one-trick pony. There's a lot of different components that go into building and designing secure software, making sure that it is running in a safe environment, and access to that software is also secured. The data that is generated is also secured at all points in time, and the access controls that are there is secured at all points in time. And lastly, you want to make sure that the computes are also secure. So there's quite a lot that we covered in this short segment. I would be happy to talk about this at length with your teams. Please make sure that if you have any questions, reach out to us at the contact information below. Talk to you soon.